Hello and welcome back to the channel Understanding.Concepts.Of.Physics. I hope you have subscribed the channel. In case you haven't done so, just kindly go and subscribe the channel to follow up more updates. Today we are going to solve one of the numericals. It's a bit long numerical. Let's see how it works. So this is the question. You can just pause the video and go through the question. Okay, so in case if you have gone through the question, the data is, one is the radius, so radius is given, that's in centimeters, so we need to convert that into meters. Then they have given the temperature of the chamber, so there is some chamber, and the temperature of the chamber is 100 degrees Celsius, that is the surrounding temperature. And they have asked the rate of energy. So rate of energy basically is the energy upon time. This is something we are supposed to find out. And they have also said that the temperature of the body is 110 degrees Celsius. So this, whatever things I am marking, these are the data which has been given to us. And then they have given the Stephen's constant, and this Stephen constant is value is 5.67. However, they have given us 5.76. So we'll be solving it by 5.76, or maybe I think so I have put 5.67. Okay, so we'll be solving this by an accurate value, that is 5.67, and not by 5.76. Okay, so these are the data given. So I just put that into a given form. So there is a solid copper sphere. It's a black body we have considered. I mean, the question says that it's 2.5 centimeters radius, that's multiplied by 10 raised to minus 2 in order to convert that centimeters to meters. Temperature of the surrounding is 100 degrees Celsius, that needs to be converted to Kelvin, so I have converted to 100 plus 273, that will give me 373. So this is 373 Kelvin. Then temperature of the body is given as 110, so 110 plus 273, that will give me 383, and sigma is given as 5.76. I'll just change this value to 5.767. So this is 67 into 10 raised to minus 8. Now this is in proper system of units, so not a problem. So they have asked us how much energy we are going to supply to this sphere, because this is at 110 degrees Celsius and the surrounding is at 100 degrees Celsius. So we are going to supply this with some energy, and how much energy in how much time are we going to supply, in order that the temperature of the copper sphere is 110 itself, and it is not going to go down, because the surrounding is at a lower temperature, so there is a tendency that the ball is going to cool down and the temperature is going to drop. But if we are continuously keep on supplying the energy, then definitely this ball is going to be maintained at 110 degrees Celsius. So we are supposed to find out Q by T, that is the amount of heat energy per unit time. So here what we are going to do is we are going to apply the Stephen's law. So by Stephen's law, so Stephen's law says that Q upon AT, that is amount of heat energy emitted per unit area per unit time, is equal to sigma T raised to 4 minus T0 raised to 4. So actually, if you remember my videos, if you have seen my videos, after Stephen's law I had given one small special case when we are supposed to find out the amount, total loss or the gain of energy. From that this formula is taken. So Q upon AT is equal to sigma T raised to 4 minus T0. So it's a tweaked Stephen's law, and Stephen's law original form is Q by AT is equal to sigma T raised to 4. This is the original form of Stephen's law. But if we want to find out the net loss or gain of energy, then we are supposed to do this thing. And I have explained that in one of my previous videos. You can just go through the playlist and just come back on this numerical. So I don't want an A over here, so I'll just move this A on here on the other side. So A is on the other side, sigma is as it is, T raised to 4, T0 raised to 4. Now A is area, and if you know the area of a sphere, then that is 4 pi r square. So area of a sphere. So area of a circle is pi r square, but area of a sphere, surface area of a sphere, is 4 pi r square. So here we are, Q by T, and every values we are supposed to put. So let's put in the values. So 4 pi ka value is 3.14, R key value is 2.5, 10 raised to minus 2 the whole squared. Sigma is 5.67, 10 raised to minus 8. T raised to 4 is 383 raised to 4, and T raised 0 raised to 4 is 373 raised to 4. So let us pull in the values. So 4, 3.14, 2.5 ka square is 6.25. So if you multiply 2.5 by 2.5, you will get 6.25. 5.67 as it is. I have just halted this part. 383 raised to 4, 373 raised to 4. Now I have taken all the powers of 10 on one side. So if you see, this is 10 raised to total minus 4, this is minus 8, so this comes out to be minus 12. So that's 10 raised to minus 12 on this side. Now what happens is if your board allows calculator, if whichever board you belong to, if that board allows calculator, then this is a piece of cake. Like if you are solving this, it's a piece of cake, like you can just solve it very easily. But in case if your board does not allow a calculator, and if they ask you to solve it directly, then things are difficult. Or maybe if they are allowing you for logarithms, then we can solve it by logarithm as well. So from here on, it will depend upon which board you are. If you are from a board which allows calculator, just avoid this part and you can just go ahead and punch the calculator and get the answer. And if your board does not allow a calculator, if they allow you direct calculation, so direct calculation, you know, I am just not focusing on direct calculation. But if you are supposed to do it by logarithm, then I have just solved it by 1. Now you won't be able to apply logarithm to the entire thing at this moment because there is a minus sign over here. So what we are going to do is we are going to solve this part first, this part next, and then the whole part. So let's see. So y1, I am just assuming that y1 is 383 raised to 4. Now the property of log says that the 4 comes ahead, so I have taken 4 outside. So I have applied log and antilog together, and 4 comes ahead. The property of log says that the 4 should come ahead, and this is 383. Now I'll try to remove the log of this. So 383, there are 3 digits, so the characteristic is 2 point, and we'll have to see the mantissa, and that is 38.3. So 38.3 will give me 5831. Now simple multiplication, 4 1s are 4 3s are 4 8s are 4 5s are 4 2s are, and you get 10.334 through 3324. And y1 I got, I'll find out the antilog. Now in order to find out the antilog, what we do is we use the decimal point, and after the decimal we see the number. So you are supposed to see 33 ka row, 2 ka column, and 4 ka mean difference. So if you have a log table, you can just add them up and you will get this number. And whatever there is in the before the decimal, you just put that in the power of 10. So this is the way how we do it. I'm going to put some video lectures on logarithm as well for people who have like struggling with logarithms. Let's see. So I have found out this part y1, and I'll now find out the y2, that is 373. So similar way, so y2 is 373 raised to 4. Log and antilog are applied simultaneously, and this 4 comes ahead. So 4 comes ahead. This is the property of log. Then 1 2 3, there are 3 digits, so the characteristic would be 2 point 37 ka 3, so that is 5717. So you need to see 37th ka row and 3 ka column, and you get this number, and that number is 5717. Now when you multiply this, you get 10.2868, and if you see 2868, 28 ka 68 in antilog table, you get 9355, and this 10 is put in the power of 10 in the final answer. So you get this thing. Just a minute. So now there is a play over here that I have solved this part also by logarithm. I mean, I used a calculator to find out a logarithm, and I would just say that this 8 won't come. Like if you see this 8 won't come, and the reason is because whenever you find out an antilog, you will get an answer in 4 digits. Same way here also, like you will not get this 5. So 1.935. So I have put those values. I have put these two values. Now since I know the values of y1 and y2, I have found out these values, 383 and 373 raised to 4. I am putting those values in my original equation. So 4 as it is, 3.14 as it is, 6.25 as it is, 5.67 as it is. 383 raised to 4, 373, this is the same equation I have just copied, but in place of 383 I am just going to put 2.1498. Of course 8 should not be there, so I'll just remove that 8. So 8 is not there, and same as 373 raised to 4, I get 1.9355, so I'll just remove that as well. So now now many people ask that where is that 10 raised to 8 10 raised to 10 went, this 10 raised to 10. Now I have taken those 10 raised to 10 outside. This 10 raised to 12 was as it is from the before. Now 4 as it is, 3.14, 6.25, 5.67. Now subtracting this, I'll get this number, and 10 raised to 10 and minus 12 will give me 10 raised to minus 2. Now in order to find out this entire thing, again you will apply log. So log 4, log 3.14, log 6.25, log 5.67, and log of this. Now the characteristics of 4 is 0, and you will have to see the row of 40 and 0, so you will get number 6021. 31.4 ka the characteristic is 0, and 31 ka 4 you will have to see 4969. 6.25 the characteristic is 0, and 62.5 you will have to see 7958. 5.67 the characteristic is 0, the mantissa is 56.7, so you will get this 7535. And if the number is less than 1, the characteristic comes out to be bar 1. Bar 1 is basically simply a negative 1. So 0 can be written, 0 point something is written as bar 1 point. 21 ka 34 will give you 3310. So this is how the log has been taken out. Now it's just a matter of addition, so I'll just add everything up, because at every place there is an addition, just except this part, because this is a bar 1 which is a negative number. So I'll add everything up, just this number has to be subtracted, this part my 1, and not this one. Okay, so bar 1 should be subtracted, however this 3310 should be added itself. So doing that part, I'll get 1.9793 10 raised to minus 2 as it is. Now I'll find out the antilog, and when you find out the antilog, you always start from the point where the decimal is starting. Like you'll have to see the antilog from 9793. So 9793 will give you 959534. Point should always be on the first digit, after the first digit, into 10 raised to whatever number is here, that should be in the power. So 9.534 10 raised to 1 into 10 raised to minus 2. Minus 2 plus 1 is minus 1. 10 raised to minus 1 say we'll have to shift the point on this side, so I'll get 0.9534. These many watts is basically the power which should be supplied to that copper sphere in order to keep the temperature of the copper sphere to be same. So this is it. I hope you have understood the entire numerical. Just go through in case if you haven't done so. If you have not followed, just keep doing it again, and subscribe the channel in case you have done so yet. Thank you so much. Bye.